Let x naught equal to 0. Define a sequence xn plus 1 equal to cos xn for every n greater than equal to 0. Then for option for this problem is given xn is increasing, option A, and convergent, option B. Xn is decreasing and convergent, option C. Xn is convergent, and limit of xn lies between even terms and odd terms. Xn is not convergent. So in all four options, we need to discuss about convergence. Convergence, you can see option A and B, and monotonicity and limit point and limit. Convergence, monotonicity, and limit we need to discuss in all four options. As x naught is 0, x1 is cos 1, x2 will be cos of cos 1, x3 will be cos of cos 1, cos 1, sorry, cos 1. It means if 2 here, then 2 times cos, if 3 here, then 3 times cos, and so on. So we will discuss, or this sequence is based on cos function. So first we need graph of cos function, and the first point is cos 1. So cos 1 is this point. This is the value of cos 1. So it is x1. So height of this one will be input of coming term. So this is around approximately this height or this length, and at this point height of the cos function is this. It will be x2. Now this x2 will become the input of next coming term. Suppose this is x2, and height of at this point is this one. So it will be x3, and now this x3 will become input for coming term, and at this point height of cos function is this one. So it will be x4. So we can generalize here. X1 is this point, x0 is 0, and x1 is cos 1, and cos 1 is some positive value, so it is greater than 0. So x0 is less than x1, and about x1 and x2, this is x1 double tick, and this is x2. You can see clearly x1 is less than x2, and x2 and x3, this is x3 and this is x4, x2 and x3. So this is x2 and this is x3. So x2 greater than x3, and x3 and x4, about x3 and x4, this is x3 and this is x4. So x4 is greater than. So once greater, then less, greater, less. So this is a two behaving sequence. Once this sequence increase, then decrease, then increase, decrease. So we separate this or make subsequences, because xn plus 1 is cos of xn for all n greater than equal to 0. So we separate even terms and odd terms. x0, x2, x4, x6, and about x2 and x4, This is x2 and this is x4 and this is x naught is 0. Suppose this is 0, x naught is 0. So this is decreasing because of x2 is greater than x4, and left this term because convergence of a sequence doesn't alter if we delete some terms of the sequence. X2 is greater than x4, so it will be, and about x4, x4 is same here, so it is decreasing, and about x1 and x3, x5, x7 and so on. You can see here this is x1 and this is x3, so x3 is greater, so it will be increasing sequence, increasing. So we need to discuss about monotonicity. It means either increasing or decreasing. Here we have two sequences. We have two sequences x2n type and x2n plus 1. This is increasing and this is decreasing. Now you can see here all values of cos function is less than, because of cos function is lies between 1 and minus 1, so it is bounded. So each subsequences, either this subsequence or this subsequence, both are bounded and increasing or decreasing, so both sequences converges. It means entire sequence convergence. If some subsequence of a sequence convergent, then we can't say about convergence of sequence. But if subsequences contain all terms of the sequence, if some sequence contain all terms of the entire sequence, and we know about the convergence of subsequences, then we know the convergence of entire sequence or larger sequence. So xn is convergent sequence, xn is convergent sequence, xn is convergent. So option B, A, B, C both contain convergent. So option D discard here at this stage because we know xn is convergent. Option D discard. And xn have two behavior, one's increasing or decreasing. So at this discussion, point A and B also discard option. Now left option is C, so it is true, and limit of this sequence will lies between even terms and odd terms.